Hey guys, and welcome back. Have you ever thought to yourself, well, that function looks a bit odd, but you had no way of knowing for sure? Well, today is the day. Hey guys, welcome back. Franck here. Subscribe to my channel if you have not done so already. Today we are going to be covering even and odd function. So formally, a function is said to be even if you can show that f of negative x equals to f of x. Basically saying that any input x you have and its opposite have the same value of y. And a function is said to be odd if f of negative x equals to negative f of x, which is basically to say that every opposite x input have opposite y output. Let me give you some example. So the first one here is going to be f of x equals to x squared. So I know for a fact that this function is an even function, but if you had to show for yourself that this function is actually even, what you would have to do is go ahead and figure out what f of negative x is. So what this means is that you're going to go into your function f of x, and wherever you see an x, you're going to replace it by negative x. So we're going to have here f of negative x equals to negative x all the way squared. And so with that, you're going to get negative x times negative x, which would give you back x squared because minus times minus is just plus. And so that would revert back to your original function f of x, which is to say that f of negative x is equal to f of x. And so with this, you would have shown that this particular function is an even function. Let me give you another example. So if you had g of x equals to x cubed, how would you show that this function is either even or odd? So you would go ahead and say, what is g of negative x? That would be negative x all the way cubed. And so that would be negative x times negative x times negative x 3 times, which would finally give you negative x cubed, because minus times minus is plus, times minus is negative. And so that will revert back to the opposite of your original function, which is negative g of x. And so finally you get here that g of negative x is equal to minus g of x. So opposite x value giving you opposite y value. And so this shows that this particular g function is an odd function. And yes, if you're asking yourself, is the fact that this function have odd and even power an indication of them being even or odd, you're right. The first function here is an x squared function. Because it's a basic x squared function, just a single variable x raised to the power of 2, which happens to be an even number, this function would in fact be even. And so other even function would include x to the power of 4, x to the power of 8, x to the power of 10, and even x to the power of 0, which is in fact just the number 1. Examples of odd function would include the function x itself, x cubed, x to the power of 5, x to the power of 7, and so on and so forth. And so with that, you should also know that every addition or subtraction of these particular functions would give you a similar result. What I mean by that is, if I look at my third example here, h of x equals to 2, x to the power of 4 minus 8, x to the power of 8 plus 1, because every single terms here are made up of even function, then this whole function h is actually an even function. And you can stop here without even having to show it formally. You can just say that every single term is even, and so the function itself has to be even. Same thing with example number 4. If I give you k of x equals to x to the power of 7 minus x to the power of 5 minus 2x, you could simply say that every single term here, x to the power of 7, x to the power of 5, and 2x are odd function, and so this entire function k of x would be odd as well. And so with that, I want to give you sort of rules that you could use to get to know if your function is even or odd without having to go through the formal definition of finding f of negative x or g of negative x. So you already know from here that an even function added or subtracted to an other even function will give you an even function. Also, an odd function added or subtracted to another odd function will give you an odd function. You should also know that an even function multiplying an even function would simply give you another even function. And also, an odd function multiplied to another odd function would give you an even function. And finally, if you have an odd function multiplying an even function, that will give you an odd function. So for this multiplication slash division combination of functions, you can think of even as being plus and odd as being minus. And as you can see here, plus times plus will give you plus always, and minus times minus will give you plus. But minus times plus would give you minus. And so with that, let me give you another example, example number 5. So if I give you, for instance, q of x equals to x square root of 1 minus x squared, and I asked you if this function was even or odd, you could simply observe that the first factor here, x, happens to be an odd function because it's x to the power of 1, while my second factor here, square root of 1 minus x squared, on the inside you have 1 which is even, and x squared which is even. A subtraction of even function gives you an even function, so this whole factor happens to be even, and so you have an odd function multiplying an even function, and so that should give you an odd function. So from here alone, you can already know, oh, this function happens to be an odd function and stop. But just to show you that that's actually true, let me go ahead and solve this and show you that this is actually odd. So I'm going to start with writing q of negative x, and I'm going to see what this turns out to be. And so that's going to be negative x in parentheses multiplied by the square root of 1 minus, in parentheses, negative x, close parenthesis, squared. And so with that, you're going to have on the outside here, negative x, and then under the square root, you're going to have 1 minus x squared, because negative x squared is the same thing as just x squared, because minus times minus is just plus. And so therefore, you have that this particular expression goes back to be your original function, but negative. And so you're going to have q of negative x equals to negative q of x, which means that this function is formally odd, right? Because that's the definition of an odd function. Next example, let's look at something else here. Number 6, we're going to have p of x equals to x in parentheses x cubed minus 2x. Again, you can look at this and decide whether this function is odd and even without having to do it formally. And so you could say that our first function here, x, happens to be odd. And then in the parentheses here, you got an odd function minus an odd function, which should give you an odd function. And so you have both of those factors being odd. If you have an odd function multiplied by an odd function, that should give you an even function. And so without having to go through it formally, I know that this function happens to be even. And now, just to show you that this is actually correct, I'm going to go through it formally and show you how this gives me an even function. And so I'm going to have p of negative x equals to negative x, and in parentheses, I'm going to have negative x cubed minus 2 times negative x. And so that should give you negative x on the outside, and then you should know that negative x cubed should give you negative x cubed, and then negative 2 on negative x should give you plus 2x. And finally, you can, if you decide to, move the negative in front of the x inside the parentheses. That will give you x, in parentheses, you're going to have x cubed minus 2x, since the minus is going to go in and change all the sign. And so you found out after all this manipulation, you're getting back your original function. And so what you're going to have here is p of negative x equals to p of x. And then from this, you can formally say that your function is even. Right? And so you don't have to go through this formal process all the time if you know these rules of even and odd functions. You can just say that they are even or odd based on the makeup of the function itself. All right, so one last thing, you may have noticed here that I didn't tell you anything about plus or minus combinations of odd and even function together. And that's because if a function is made up of odd function subtracting or adding with even function, then the result will be that the function is neither even or odd. So for instance, if I give you a function v of x equals to 3x to the power of 4 minus 5x plus 1, you can look at this function and notice that your first term happens to be a power of 4, so that's an even function, but the second term here happens to be a power of 1, so that's an odd function. And so with that alone, you can stop and say that this function is neither even or odd, because they are both odd and even terms making up your function. And so from that, you should be done. All right, so on my next note, I'm going to show you how to determine if a function is even or odd based on their draft alone. And so I will see you next time. Bye-bye. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.